Let us discuss about the rate of photon emission from a source of light. Say we are given with the source of light, say there is a torch which is of power p watt, that means it is emitting p joule of light energy per second. Say it is emitting light which is of wavelength lambda. Now in this situation we know energy of each photon emitted is, if the light wavelength is lambda, then energy of each photon emitted we can write as hc by lambda, or in terms of frequency we can write it h nu. Now in this situation, per unit time it is emitting p joule of energy. So here we can write, if n photons are emitted by the source in 1 second, then we can say in 1 second total energy emitted is p watt, which is in form of photons only, and each photon has energy hc by lambda. So we can directly write the number of photon emitted per second will be p divided by hc by lambda, as p is the total energy, hc by lambda is the energy of one photon. So number of photons emitted per second can be given as p lambda by hc. So these much number of photons per second are emitted from the source which is having a power p, and it is emitting a light of wavelength lambda. That is the rate at which the source is emitting the photons. The only difference in various type of sources is the directivity. Like in this situation of a torch, we have considered all the photons are emitted only in one direction. If there is a point isotropic source, then we know that in case of point isotropic source, light is emitted in all directions uniformly. So in this situation, it will emit photons in all directions in the surrounding of, in the three-dimensional surrounding of the source. So total emitted photons will remain p lambda by hc if it is again of power p watt and the light emitted is of wavelength lambda. So the basic difference is only the directions in which the photons are emitted. The total rate at which the photons are produced and emitted out from the source will remain p lambda by hc photons per second.